what are these plots called down here, by the way? They're dot plots. I told you that in the instructions. It says examine the following 2 dot plots that show the scores on a 10-point quiz of 2 different, very small classes of 10 students. It wants to know for each one what's the mean and the median. Now, this is a small set of data. It'd probably be easier just to calculate the mean and the median versus putting it in our applet like we did yesterday. Okay? So if we look at this first one right here, I'm going to look at Class B. They have, 7 plus 7 plus 4 eighths. And 2 nines. Okay, so when we do the mean, we'd add all that up. So that would be, math in my head, 14 plus 8 times 4, 32, plus 9 plus 9, 18. And so that would give me 64. I'm going to divide it by 8 scores. So the mean was 8, okay, on that one. So I just did that quick arithmetic in my head. The median, that would be the middle value since there's 8 of them. 2, 3, 4, 1, 2, 3. There's 2 numbers in the middle. We'd add them up, divide by 2, but they match, so it's just 8. Okay, so for Class B, the mean was 8, the median was 8. If we look at Class A, okay, so I've got 4 6s and 4 10s. All right, so 1, 2, 3, 4. 1, 2, 3, 4. So again, 8 scores. The mean, okay, if I add that up, let's see. 4 times 6 would be 24 plus 40, 64. Divided by 8, which is 8. All right. And then for my median, again, if we look at the middles, I'd have 6 plus 10, so there's 2. I'd add those together and divide by 2. 16 divided by 2 would be 8, okay? So they happen to have this exact same mean and median, okay? But do they look the same? No, okay? How would you describe the shape of that top class, Class B? It's symmetric, okay? It's symmetric, all right? What about this last one? It's a weird version of uniform, but it's actually uniform, okay, because they both scored the same. It's the far ends, but they both scored the same. What do you think that means in terms of how the classes did? Which class were the scores more spread apart? B, okay? So you had a group that made 10 points, you had a group that made 6 points. They were really spread apart. But in Class A, they just went from 7 to 9. So everybody scored more about the same, all right, in Class B. So that's what we're going to talk about today. How do we get the same mean and median, but the data looks so different, all right? And what does it mean? So things we're going to discuss today. Okay, talking about range, something called the standard deviation, and then something called the interquartile range. And so we're just going to discuss all of that. Okay, alrighty. So I asked you guys in your survey when we started Unit 1 about how many different colleges or jobs or trade schools or military branches were you planning on applying to as part of like your future plans after you leave here. And I listed all of that for you on the blue sheet that's on your table, okay? And we're not going to list all of those, okay, because we ain't got that kind of time. Y'all with me on that? But looking at that table or looking at that sheet, what was the smallest value that was in the table? 0, okay? Some of us don't really plan to do any of that. Maybe we're just going to go to work. We've already got a job or we've already got a trade planned out for us. And what was the largest value? 25. We're going to consider all the options, all right, at 25. That's a lot of colleges, a lot of job applications, you could apply to all 4 military branches with that, right? So a lot of options for you. What would be the difference between those two? Be 25. 25 minus 0 would be 25. When you do that, when you take the smallest value and the largest value and you subtract them, that's the range. And that's one of the things that I had you guys do the other day, okay? That's the range. If we take the largest minus the smallest data point that we have, that's always going to be your range. Okay, so that's an important definition that you're going to need. All right, range is large minus small. Okay. Now, the next part, it asks us to do it by hand. And guys, I'm just going to be honest with you, we're going to skip it, okay, because we can, all right? It asked me to find the median, okay? It asked me to find the median. So how did we do that yesterday? Where do we go to find the median yesterday so that we didn't have to do all the work? Statsmedic.com/applets. So that's what we're going to do again. Okay? It's our favorite site. We're going to use it a lot. I would bookmark it. Okay? If you know how to bookmark it, bookmark that bad boy. We're going to choose the one quantitative variable, which is the first, I think the fourth one down. And I want you to take a second and to put that data in, all those data pieces that we have there, all right? And we're going to put those values in, and it's going to give me the median, okay? It's going to give me the median. So that's our applet we're going to use. So take a second and do that. Let's get all that data put in. Let me get mine put in back here. Okay. Statsmedic.com/applets. All right, we're going to choose that one quantitative single group. And I guess you can just call this the future or whatever you want to call it because that's what we're looking at. Okay, I'm going to reset all of that. Yep, I'm sure. All right, I'll call it future because that's what we're looking for. And let's get all these numbers put in. Okay? Okay, just checking. All right. So get all of our data put in. Then once we've got it all in there, what do we hit? Begin analysis, okay? If we want it to do its job, we tell it to begin analysis. Okay? Yeah, grab your computer. Remember, it'll always show us the dot plot, which is fun. Do we think there's an outlier in this one? Yeah, I think so too. Okay, one that's way far away from everybody else. Yeah, I think so. The rest of us seem to fall all right here between 0 and 8, and then all of a sudden, boop, out here at 25. Okay. Where do we look for the median once we have put all the data in? Where's it at? Yeah, it's in this summary statistics, and it's the one that says MED. Okay, it is my median. So my median right there is 4. Now, I'm going to take a screenshot of this just because I want to show you something, but this is really awesome what just happened right here, because if I have this table, even if I don't know all the data, okay, so I don't have all the data, I can still do a lot with this math. All right, I mean a lot with this data. So let me save that. Let me go back over here. Gonna insert my picture. Okay, so I'm gonna shrink this down. All right, so that's where we went to statsmedic.com. All right, so we know that our median, all right, is 4. Okay, my median is 4. Okay, so if my median is 4, now remind me again, what does median represent? It's the middle, okay? If I put all the numbers in order from least to greatest, the median was my middle. Now, one of the things that it asked me to do right here, okay, was to split the data in half, and that's what the median does, okay? So if we took all of our data and we lined it up, 4 would be in the middle. So we'd have this lower half, and then we'd have this upper half, okay? Those are referred to as just where 50% of the data would be, right? So I've got half on one side, half on the other. If I split it again, okay, so I've got the median here in the middle, and I split this part and I split this part. How much is now in each little section? How much percent? 25, okay? So I'm going to split it. I'm going to split it into 25% sections, okay? I'm going to split it in the middle of the bottom half. I'm going to split it in the middle of the top half. Those are referred to as quartiles, okay? We use that word quartile, like quarter, 25 cents, 25%. It's a fourth of the data, okay? So the median of the lower half out of my chart is that Q1. And so if I pulled that from that chart, it would be 2. Okay. The median of the upper half, if I took the upper half and I split it in 2, that would be Q3 or quartile 3, which would be 5. Okay. So I've got the big median, the median of the front half, the median of the high half, okay? So I've got a quartile, the median, and another quartile. If I do the difference between my two quartiles, so 5 minus 2, what does that give me? 3. This is a measure known as the interquartile range, okay? So it's not the big range. It's the range between the quartiles, and that's a value we're going to use, okay? So that we won't use it today, but we'll use it tomorrow. It's called the interquartile range. You'll hear me abbreviate it as IQR, okay? So interquartile range. Quartile 1 is the median of the low half. Quartile 3 is the median of the upper half. Now, the other thing that we can see from this table, when I do range, I take the smallest value minus the largest value. What label in this table would tell me which one is my smallest value in that table of statistics, that summary? The minimum, okay? So my smallest value would be the one that says min. That's where that 0 came from. So that's in my table. The largest value would be called the max. And so again, we can pull range from the table. We have to do the subtraction, but I can pull those numbers from right there, okay? So if I want to do range, max minus min, okay? Interquartile range, Q3 minus Q1. So I don't have to do any statistics, really. I don't have to do any work. I just put the data in and do that simple subtraction, which is nice. So there's 2 new measures, 3 actually, new measures that we can get, okay? We can get range from that table, we can get the quartiles from the table, and we can get the interquartile range, which is nice, all right? So all of that from the table. If they just give me that table of summary statistics, I can do all of that work even if I don't know any of the data, all right? Which will happen from time to time, okay? But then that other measure that we need to talk about is something called a standard deviation. And that's really a big fancy way to say, what is the average distance from the mean, okay? The average distance from the mean. And there's a reason we need that number, okay? It comes up in a lot of things that we do later on, okay? The average distance from the mean is known as the standard deviation. Now, I'm going to write a few things down that I don't want you to write down, okay? I want you just to watch what I'm going to do for a second because we're not going to have to do all this work, okay? So I want you to appreciate that we don't have to do all this, okay? So anytime it asks about the average distance from the mean, it is the standard deviation, okay? To do that, the first thing we need is the mean. What was the mean in this table? That 4.48, right? That was my mean, okay? In order to find a standard deviation, I would have to take every number that we put in, okay? So I'm just going to write down the first few. 5, 8, 4, 4, 3, and another 4. So I'm just going to write down the first few, okay? The first thing I would do is distance from the mean, okay? So I would take my number 5 minus 4.48, and I would write down the distance, okay? And I think, correct me if I'm wrong, that's 0.52, okay? I could be wrong about that, okay? All right. Then I would do it again, okay? So then I would do 8 minus 4.48, and that's going to be 3.52. And then 4 minus 4.48 would be a negative 0.48. All right, and so it would happen again. All right, again, you don't have to write any of this down. I just want you to watch. Okay, and so this would be negative 0.52. Oh, it could be wrong. I think I'm wrong about that. Anyway, it doesn't matter. Okay, now not only do we have to subtract, we also have to square it. What does it mean to square something? What does it mean when we square something? Let's do something simple. What if I did 2 to the second power? What does that mean? 2 times 2, right? 5 to the second power, 5 times 5, okay? So we would have to square those numbers, and we're going to get some really crazy numbers, all right? This is going to be a little more than like 2.25. This one's going to be 10 point something, okay? This one's going to be like a positive 1.16 or so like that, okay? So we're going to get these numbers. Then we have to add all those numbers up, okay? We have to add all these numbers up. So we would add them all up. And then and only then, we would take the square root of that number, okay, or we do the average, sorry, okay? We do the average. So we take the total, and we would divide it by our total number of points, which we had 26. So I'd have to do that for 26 different points, okay? And then once I'd done that, I'd have to take the square root of the answer, okay? So then I would take the square root of my answer, all right? That is the standard deviation. Aren't you glad we don't have to do all that? Okay, I'm thrilled because back in the dark ages when I took statistics, I had to do it all by hand, okay? Back when we wrote on stone tablets and dinosaurs were around, okay? Like, that's how old I am. The good news is, if you go up here to your chart, do you see this box that says SD? That's your standard deviation. It's just going to give it to you when you put the data in, okay? So make yourself a note down here. SD equals standard deviation. We're going to get it straight from our summary statistics, okay? It is SD in our summary statistics box. That is standard deviation, okay? So for me, or for what we got, what did it say up there? 4.691, okay? So SD is equal to 4.691. And if I did all that math with every one of those 26 data points, I subtracted it from the mean, or subtract the mean from it, I square it, I add it all up, I divide by 26, and then I take the square root. I should have gotten 4.691, okay? Now, there's a symbol that we use for standard deviation, okay? And it kind of looks like a sideways 9, right? That's a symbol that we use for standard deviation. You may see that in like some of the words in some of a problem, okay? I just want you to know that's what it means, all right? That little sideways 9 means standard deviation, okay? So what we would say, all right, this is what it means, that the average distance from the mean is 4.691. So if you're ever asked to interpret a standard deviation, it is the average distance from the mean. It's what you will say every time. Okay, it is the average distance from the mean. Okay. These are what we refer to as measures of variability. It's how the data varies. Okay, range, how does it vary from the biggest to the smallest? Interquartile range, how does it vary between the quartiles? Standard deviation, what is the average distance? How does it vary from the mean? Okay, so that's why they're referred to as measures of variability. Okay, so the main thing we got to do, get our data in the applet, pull the right things out of the table, explain it the right way. Okay, that's what we're doing, which is kind of nice. All right, we don't have to do all the hard cranking it out arithmetic. All right, so flip that page over. Let's consolidate that into some nice, concise little tidbits so that we have it, and then we're going to look at some problems. Okay. All right, rock and roll. Measures of variability. Okay, so write this down. If they say something about measures of variability. Okay. Number 1 is the range. We're going to do maximum minus minimum. Okay, we're going to pull that from our table. Maximum minus minimum. All right, so that's our first measure. Our second measure is our standard deviation. That one they're just going to give to me in the chart, SD, or that little sideways 9. Okay. If they ask me to interpret, it is the typical distance from the mean. So anytime you're doing one where there's a pull down and they ask you to explain or interpret SD or the standard deviation, it should always say typical distance from the mean. Those are the words you're looking for. Okay, typical distance from the mean. Okay. And then the last variability measure that we have is the interquartile range. Okay, I will abbreviate that IQR because I don't want to write all those words. Okay, interquartile range, IQR. We will take quartile 3 minus quartile 1. So out of our summary statistic, Q3 minus Q1. Okay, this is how we interpret it. That represents the middle half of the data, okay? Between those two numbers is half the data. So we say the middle half of the data has a range of, and we would just subtract the 2. Okay, we put that value in. What happens when I subtract? The middle half of the data has a range. All right, so 50% of our data is always going to fall between those 2. Yesterday when we talked about mean and median, we talked about them, one being resistant to outliers and one being non-resistant, meaning an outlier is going to change it, okay? The same is true about these, all right? If we're looking for somebody who is, when we're talking about outliers, resistant, meaning that an outlier is not going to change it, okay, is the interquartile range, IQR, right? If I have an outlier, the IQR should stay the same, okay? The outlier will not change it. But the other 2 are non-resistant, okay? Meaning if I have an outlier, it's definitely going to change. And that's my standard deviation and my range, right? Because if range is the biggest minus the smallest and I have an outlier, that's going to change my range. Right? It's going to change it, so that's why it's non-resistant. All right, so let's go back and let's look at those bags of chips we talked about yesterday. All right, those bags of chips. They gave you the dot plot. Did they give you the summary statistics? No, they didn't, did they? All right, but I'll tell you what let's do. Let's go in and let's put that data in the applet, okay? So my dot plot should match what they showed me, all right? But go ahead and put them in so we can see the summary statistics, all right? You can just call it chips if you want to. Right, so put those values in. I like that they gave it to me in a chart and on a dot plot. Sometimes the dot plots, it's hard to pick out the exact number if they don't label everything. All right, so once we get our summary statistic box, we're ready to go. If I'm going to do range, what are the 2 things that I need out of that box? Max and min, okay? So we're going to take max minus min. What was my max? 59. And what was my min? 19. And so the range is 40, all right? So that's all it wanted me to do, okay? Take the max minus the min, and I get 40. Question on that. Okay, we're just going to pull it straight out of the box. Okay. Then we want our standard deviation. Again, we're just going to pull that straight from our summary statistic. What number does it give me for that? 10 point something? 10.181. Okay. Now, that's easy to pull out, but let's talk about what it means. Okay. What does it mean? Well, it means that the typical distance from the mean is 10.181. That's what it means, okay? The typical distance from the mean is 10.181. Okay, so the interpretation part is what's going to be in those drop-down boxes when you're looking at your practice questions, okay? Where you interpret. And then let's do interquartile range, okay? What do I need to be able to do that? Off the table. Q1 and Q3, we're going to take Q3 and minus Q1. That's why we need a calculator, okay? So Q3, was it 49? And Q1 was 39. And so the difference is 10, okay? Again, how do we interpret that, okay? We would say that the middle half of the data has a range of 10, okay? It's just 10 apart, all right? I'm not concerned about that last question, okay? So it has a range of 10, all right? So what do we think? Too terrible? Yeah, we just basically have to know those first few things, and then we're good to go, all right? Let's see. I want to look at a couple of things. Let me look. Which problem I want to do. Okay. All right. So this is one. Let's see if we can do it without putting it in the applet because it's just asking about range. Okay. It's just asking about range. So looking at it, take a second. See if you can find the range of that distribution. Okay. Because that's all it wants. We shouldn't have to put that all in the applet because we don't need it all. Okay. So for range, I need my max and my min. What's the largest number in that list? 85. What's the smallest number in that list? 5. 85 minus 5 gives me a range of 80. Okay? So if it's only asking about range, you can probably avoid putting it in the applet because we can see that. Okay? Any of the rest of it, I'd put it in and know for sure. Okay? So not too terrible. All right. We're not going to do that one, but let's talk about how we would do it. Okay? It gave me a dot plot, and it asked me to calculate the standard deviation. Okay? I'm going to want to use the applet because it's going to do the hard work for me. All right? How are we going to get the values that need to go in that line where the numbers go? We're going to look at that dot plot, right? There's one dot above 1. There's one dot above 3. There's 3 dots above 4. There's one dot above 5, one above 7, one above 8, one above 9. So this is what we would put in the applet, okay? So don't be surprised if they give you your data in a dot plot or they give it to you in a stem plot and you have to put it in, okay? So they're going to ask you to put your data in lots of different ways, all right? I'm going to trust that you can put it in and look at the table for the SD, okay? And then we could interpret. So just a reminder that that's where we would put it, okay? If we interpreted it, once we found it, remember it's typical distance from the mean. You don't have to write that down because I've said it 975 times today, right? But anytime you interpret, that's what we're saying, typical distance from the mean for standard deviation, okay? Typical distance from the mean. All right. Let me see what else I left on here. Not too terrible much. All right, interquartile range. Again, I would put it in my applet. I'd do Q3 minus Q1 and get my number. Okay. Please stop throwing the toys or I'm going to take them out of the box. Had to tell First Block that as well. Y'all are not alone. Okay? It's one thing if you need something in your hand just as a distraction. It's something else if you distract the whole room by throwing stuff. Okay? We're not kindergartners. All right. And then that's it. Okay? So your assignment today, I believe it has 5 questions. It's probably not up. Let me open it up for you. Okay? And I'll let you go ahead and get started on that. And then we'll take our break here in about 10 minutes. Okay? A little less than 10 minutes.